Another podcast after what? 2 months. Last we recorded was in November, and now we are back. And I think let's kind of go over and talk about what all happened in the two months.
Hmm.
Well, I'll go first. I got married.
Yeah.
Life changed. My territory was taken. Uh, yeah, that happened
You
on
are
my
you
side.
are no, you are no longer street dog.
Yeah, it's like two of us now, street dogs. But I remain a street dog.
No, you are now a civilized dog.
Oh yes, I'm a pet dog. Oh no, why? I'm letting this out on the internet, man. This is anywho that happened, and I'm very glad that that happened because it was pending since long, and at least that was one of the reasons why we were away. Everybody was helping me manage things,
Yeah. We were
plan
the
things.
hero of Studio Vansha.
Yes, yeah,
Cool
and
drinks like a
that's
jar. Yeah. Anyway.
yes. All of that happened, and that's like kind of behind us now. We're over with that, and a few of us were on travel. Rajat was away, uh, you know, and now we are back, and hopefully, we continue to add more videos in the coming
Hmm.
days. So, ठीक है, that's that. And now maybe does anybody want to pitch any topic for today? What should we talk on?
Hmm.
I think we can go and talk in general about things that has been going around for the past 2 months.
Okay, sure.
So one of the growing concerns that I have been seeing over LinkedIn and people asking is, and a lot of people are making YouTube videos around it, is about the job market,
I see.
the number of job cuts people are seeing in the market, and it's not about the layoffs; it's about the new jobs coming in, specifically in the semiconductor industry. So there has been a like we have already seen 2 quarter results, and for the this and for the 2 quarters we are seeing revenues going down, not going
Hmm.
down, they are like falling,
Okay,
and
please.
so for example, and I may not be right on the numbers, but I think my previous company Microchip was somewhere around making they touched the 2 billion a quarter run rate, and the latest estimates were around 1.4 or something. Again, I think if interested, you can go and read the earnings call. That will be much accurate place to
Right,
go,
right, right.
because I'm just reading the numbers that were top of my mind. I don't remember the exact numbers.
That's fair. So it was like some number X, and now you see that it's
Yeah,
not X, but it's like a
yeah,
cliff
it's
downwards.
people are, and the same is observed with Texas Instruments.
Okay.
Like they were making huge, now they're back to what they were. And so what is happening right now, and and somewhere I read that Samsung has seen around 33% decline in the
Oh
revenue.
wow. Okay.
And so a part of the reason is, again, I would say, the unprecedented demand that the semiconductor industry saw just after COVID. There was a chip shortage where people were not getting enough chips to make things. So
Hmm.
what practically OEM started doing was starting building their inventory,
Ah, I
so
see.
that
I see.
their customers, so that they can make products without customers facing any difficulties. And what is happening now is that demand is getting saturated, but they still have huge inventory that
Inventory.
they piled up
Right.
to make sure that if the demand keeps on increasing like this, they should be able to meet the demand.
Mm.
But now they have inventory, but the demand has gone down.
Hmm.
So
Mm-hmm.
all the OEMs are doing correction in their inventory.
What
And
does
when OEMs
correction in?
do when OEMs do correction in their inventory, the inventory of semiconductor industry also goes
No,
for a
what is the
correction.
So,
correction in the industry? Sorry, correction in the inventory. What does that mean?
So, for example, let's say Cisco assume that the data center business will keep on growing like this, and to meet this, where they needed 1,000 switches, now they will need 3,000 switches for the next year. So they buy in advance chips for to make sure that if somebody asks us 3,000 switches, we should be able to manufacture them.
I
But
see.
the demand didn't go to 3,000, rather it's saturated at 1,500. So now they have 1,500 extra chips to make 1,500 switches.
I
So
see.
why go
Okay.
and buy new chips?
New chips
Hmm.
make sense. Makes sense. So
So,
they'll just
Rajat,
use their inventory.
hmm, uh,
Yeah.
you touched upon, like, like the time right after COVID was like the main culprit behind it, because the
No,
surge in demand.
so it was COVID that did this actually. So during COVID, what a lot of semiconductor industries did is they saw a lot of demand going down. So they reduced the inventory. They stopped, they put factories on
Hmm.
hold, didn't manufacture much. That indirectly
Hmm.
led to chip shortage that we
Hmm.
saw after COVID, where,
Okay.
because there was not inventory, how much it was required. So
Hmm.
in order to meet that, so they saw a huge amount of increase in revenues, and it was assumed that it may keep on going forever, and you don't want to leave trailing behind
And
if it
so
keeps
my point was
forever.
just that I think you touched upon it. So why was it assumed like that? Like, these are big giant corporations, right? They would know that, hey, this is not sustainable. This is only for few
Yeah,
years.
yeah. So, so I remember one of the calls that happened at the microchip. The semiconductor. This is not the first time such a thing is happening in semiconductor industry. The semiconductor industry is very much cyclic, as our CEO of my ex company used to say. It if even if it grows very hard drastically, it comes back and
Hmm.
keeps on going.
Okay.
Um, what is happening is this time it was a bit different. The gap is a bit more, and but everybody was prepared for this. I don't think a lot of semiconductor industries went bullish like software industries did,
Hmm.
and then did a layoff, because still we have to see a very big layoff in the semiconductor industry. The only last announcement was from Qualcomm, and that was only 1,200, not that much.
No.
But Qualcomm etc. are still mobile chipset. The majority of the semiconductor companies are the small chip makers, which make chips for automotive,
Right.
industrial, etc. NXP,
Right.
TI, analog devices,
Hmm.
microchip, Renesas, etc. So we have still not seen layoffs over there. So they were prepared. They didn't go very bullish that okay, our business is gonna double. Let's double our
Hmm.
strength.
I think. I
Uh,
think. I suppose
at
those
least,
who.
during my time at Microchip, at least our CEO used to say this, that he doesn't want to go all bullish around this.
Okay.
Like it's a cyclic industry, and you don't
Hmm.
make long-term bets on short-term
Oh,
increases.
right. Right. I suppose those who wanted to, like, make instant profits out of the COVID wave, those who saw that opportunity, maybe, gave in the orders for chips and all of that, and later they
Hmm.
could not convert them, and um, yeah,
Yeah, so you
Yeah.
should
that's how
see
the
this thing
inventory
like
piled up.
it's not like software industry. Inventory in semiconductor means you expand your factory, you buy in more
Hmm.
wafers. So this is
Hmm.
like actual things that you can't get rid of.
Physical stuff, yeah.
Hmm.
These are physical bought
Hmm.
stuff.
Yeah.
So
And
it cannot be like you double your factory and then nothing is happening. So I will sell off to the other factory.
right, right.
You are going to
Also,
make a huge
who's
loss. Of,
true, and
yeah,
who
who
is
is
going
going
to
to buy
buy it?
it?
Hmm.
Who is going to buy it in a falling market? And also, it's a huge loss selling back the factory.
Yeah, yeah. And also, I want to, get your opinion on this statement. Like, for especially for the semiconductor industry, the statement is that if you want to double your revenue, you need to double the workforce. How correct is that?
That doesn't happen in semiconductor industry.
So wait,
So I
this.
always say it is not that easy to double the revenue in semiconductor industry, specifically in companies where you have personal computing is different thing. Personal, when I say personal computing, I mean watches, fitness trackers, your mobile phones, desktop, etc., where people have a refresh cycle of 2 3 years, and that is also going down year over year now.
Hmm.
People are not refreshing their phones every year now. That trend is also going down. When I talk about major semiconductor industry, I majorly talk about industrial and automotive customers because I majorly come from that background. So there, if a socket is gone, it's taken. That socket is now taken for 10 to 15 years.
Hmm.
Nobody
Hmm.
is replacing that socket for next at least next 5, 10, or 15 years. So
Mm.
if let's say NXP wants to double their revenue, so it's either via new opportunity. So a
I
company in
see.
semiconductor can only increase their revenue by either getting new customers on board or replace or taking some other company's business. For example,
Mm.
if socket was with microchip, I will grab that socket and make it an XP customer. But the thing is, the socket is blocked for next 5-10 years, so it's not easy to grab that socket. So you need to get new customers, get new fields, etc. So it's not that easy to double your revenue in semiconductor
Hmm.
industry. That doesn't happen organically. It's not very easy to double the revenue.
Fair. By the way, the state.
Inorganically you acquire some company, you get their company's
Hmm.
business, so majority is like inorganic doubling. You get you buy another behemoth like analog devices goes and buy Maxim. Now all Maxim customers are analog devices customer, and analog devices revenue is 60% up, but that 60% up is not actual semiconductor revenue that you increased. You just ate away your competitor. So that's still the same socket. You didn't suddenly market didn't see 60 new sockets.
I see. So the product still stays in the
Yeah,
market. It's just that one company was acquired by another, something of that nature.
yeah.
Hmm.
By the way, what was the statement, Mohammed? Could you repeat that?
So
To double
specifically,
the.
yeah.
And where
So
is it coming from? Is there a background to that?
no. I just wanted to know more about, how does that work? Like in software world, that, you don't need to double the workforce to increase your revenue multifold, right? It grows like the
The
workforce
leverage
grows sort
is.
of logarithmically while the revenue grows exponentially.
I see.
Yeah,
Okay.
I wanted to know whether the same relation holds in semiconductor world
I
as
see.
well or not.
I
when
see.
you talk about the software industry, the what is a tap? What is the revenue that you can grab by becoming a software company? There is no limit on the revenue that you
Yeah,
can
yeah.
earn.
Correct. It's value
Mm.
add, right? The
Hmm.
more.
It's value addition.
Hmm.
You are potentially you have the 8 billion people as your
Hmm.
customers, but that's
Right.
Yeah.
not true for semiconductor. The
Hmm.
fastest growing and the bullish semiconductor area is definitely connected world, where cars are
Mm-hmm.
becoming much more automated. You see much more semiconductor going over there. Industries are becoming much more automated. The digital revolution is what industry calls it.
Mm-hmm.
Is the most bullish thing that is going on in
Right
semiconductor.
now, right. But
So, so
do you?
Rajat,
Go ahead. Go ahead. Sorry.
so Rajat, like in these days, people talk about a lot about IoTs devices and all
Yeah.
of those things, right? So that should, like, everybody is now using, those devices. So that should increase the semiconductor requirement, right?
Well,
And
if you look at after COVID, the biggest chip shortage was in automotive industry. A
Hmm.
lot of like that waiting for the cars went up like 9 months because they were not getting chips. A
yeah,
lot of car vendors started cutting features where you need a semiconductor to control that feature. They were like, if you are ready to take it without this feature, we will give you the
Hmm.
car delivery.
yeah.
And a lot of companies did feature cuts in automotive, but now people are seeing the same thing. Automotive is back in line and it is going like stagnant, but semiconductor industry already increased their inventory to meet the chip shortage of automotive industry.
But
So
why don't
when
they
you
pivot to the IoT devices, right? Since
This is
uh,
IoT, right? A lot of cars are getting connected now, so your complete infotainment system gets connected now. So this is still IoT. And
okay,
there are multiple sections of IoT. IoT is a very broad term that has been put like 20 years. And
mm,
IoT just simply means you connect everything to each other. Correct?
right.
A lot of automobile
yeah.
industry is moving towards it, if you see.
Well,
So,
I
but,
mean,
but
if
yeah,
there are like Google Maps and YouTube on the dashboard, then your car is connected to the internet.
Yeah.
right. And I was majorly talking about the devices that we use daily in our house, right? And each device requires two or three chips, right? And that should increase if get more and more customers, use those IoT devices, right?
Yes, but with the inflation increase, the interest rates increase, etc., a
True.
customer is not spending that much, right? The
Right.
spending power of the customer goes down.
Yeah.
Well, also, I just want to kind of pivot, our discussion back to the
Yeah.
semiconductor. Were we saying that the semiconductor chip supply is available, but the demand is not high now because of the inventory,
Yeah,
right? And what we are talking about now, I suppose, is the home automation and IoT around home automation.
yeah.
And shouldn't the increase in home automation somewhere nudge, like,
Yeah,
the usage of the chips?
yeah, exactly. So that's what my whole point was to explain that this is temporary. The semiconductor industry is very cyclic. When good time comes, bad time follows. But when bad time comes, good time again comes back. So it's a very temporary solution. It's a correction that is happening in the inventory, but things will be back on track once the inventory corrects.
Hmm.
It's not a situation where you should panic and be like jobs, the jobs nahi hai semiconductor mein, jobs nahi hai semiconductor mein.
Hmm. Hmm.
The same is going on in software.
But
You
I
are
think in
getting
a
jobs.
lesser scale than.
Not actually, right? It is happening much more in software. The reason,
But
so
I suppose you
software,
have
you're
more
getting jobs.
opportunity. Huh. In.
There are more companies, but as
Hmm.
well, there are big layoffs happening in the
Hmm.
software industry.
Hmm.
Specifically because everybody in software as well assume that the business will keep on
Yeah.
growing.
Yeah.
Hmm.
I suppose people are more used to the corrections on software world, so that's why there has been not much of a, you know,
Yeah.
pushback rather. But in semiconductor world, like, as you said, it may be cyclic, but I think this is. Would you say this is happening at a larger scale right now, or it's?
Well, if you look at it's a cyclic. Not all semiconductor industries are having a bad time, right? Qualcomm and Nvidia are having decent time. Nvidia is having a brilliant time. They are
Brilliant.
like doubling their revenue.
Yeah. We were talking
So
about the
it's
market cap, right?
Yeah.
yeah, not market cap, even
Revenue
revenue
as
as
well.
well. Their revenues are increasing drastically.
Think
So
they
if you
rode two
look at
big waves, right? Two big
yeah,
waves. One was,
The AI in
Bitcoin, AI,
automotive.
the blockchain first, and now AI and automation.
yeah, so you can see it exactly right. So the industrial and automotive are OEMs are stagnant. That's why the semiconductor industry that focuses on
Hmm.
these two are stagnant. But the semiconductor industry that is focusing on, let's say, AI,
Hmm.
they're booming.
Yeah, yeah.
AMD is booming, Nvidia is booming.
And I suppose now we are being like the industry is judging, the in companies by the
The
viewpoint
AI.
of AI classes. Like, hey, what are you doing in AI? If you are good, rather even opening a AI research center, you are good to go.
Yeah,
Otherwise,
yeah, yeah. I think AI is,
hmm. And we should
yeah,
talk more about AI, but in a like a different
context.
spot.
Yeah,
Yeah,
yeah.
Different context.
Different context and even different podcast, I
yeah.
suppose. Cool. And then, any opinion on the entry of ARM in the
Hmm.
computing? What is the field? The IPO
Desktop,
or the
desktop market.
desktop computing? Yes, yes. I know that
It's like
Microsoft somewhere was, using ARM-based chips
Yeah,
for their
yeah. Surface.
Surface line of products. And well, there was also somebody who sent me, like someone sent me a link to an article which talked about um, like Windows being, developed for
Yeah,
yeah.
yeah, yeah.
something like
It
that.
is. I think it is already
It,
done, basically
yes,
ported
it is
and.
already done. I do know, but anyways, I forget the exact
So the
news.
beauty about this industry is that everybody knew that ARM may be more power efficient, but nobody wanted to take that risk. Apple
Right.
went ahead, took the risk, make Apple M1, and now everybody wants to make a
Yes.
ARM-based chips for
Hmm.
desktops.
Yes. And Qualcomm recently did that, right?
Yeah.
Yeah,
Yeah.
if you look at pure benchmarks, they are like on par even with Apple M3.
Ahead. Yeah, they are
Yeah.
ahead
Even
in some cases.
they are ahead
Gen four.
in M3.
What was the
Hmm.
chip called? X
X
something.
Elite, X
X
Elite.
Elite.
Excellent.
X Elite. Right.
But let's see how it turns out. But it will be amazing to see. So I don't know. It to me it feels like a change of era, right? So it's like
Uh-huh.
Mughals going out of power and Britishers coming in India, then
Something
Britishers
like
going out of power, India getting independence. So
that. Right.
Intel getting out of Intel's future looking drastically bad for desktop market if
Hmm.
they don't improve, and ARM taking over or RISC-V taking over. You don't know
Oh
Hmm.
yeah, yeah, yeah.
where it goes.
Somewhere, well, with respect to RISC-V, what I know is Western Digital is like a huge proponent of the architecture, and I suppose their SD cards, the memory management
Hmm.
unit,
Yeah,
are now RISC-V
yeah.
based. This is, by the way, coming from presentations from the RISC-V org, that YouTube
Right.
channel saw somewhere there. So apparently, the market will see like a surge of microcontroller class of RISC-V processors, and I suppose we still have time before RISC-V architecture can take over, or punch
Hmm.
heavily in the desktop or the application class of processors.
Well, I
But yeah,
actually always see it in the opposite direction. If RISC-V is gonna enter and get popular, it will be first in
Microcontroller.
desktop market. Desktop market.
desktop market. Okay,
Uh,
why so?
Oh. Hmm.
Because my view is
Well, I
Fizzle.
currently,
always
My is like Piyush. It would be like, start slow, prove yourself, then
and then
conquer new
incrementally move.
territory. Yeah.
Yeah, but this is an
well.
interesting opinion. Go ahead.
I always believe so is because entering this, so there are different microcontroller markets. There are personal computing microcontrollers. There's or industrial. There's automotive. It's not that easy to change sockets in industrial and automotive. Like people
Mhm.
don't want to change their stack so often.
Mhm.
While that's not true for personal computing, there are microcontrollers that go into personal computing as well.
Right.
So that's the places like security chips may move to RISC-V, which are anyways like a
I
very
see.
ARM was anyways not contributing anything over there.
Wait,
It was
hang
just
on. So
regular.
when you were saying application, you are saying embedded application, not the desktop
A
compute
class,
application.
A class
What
Application
equivalent
I
of.
processor kind
so
of.
Hmm.
I don't want to say applications or microcontrollers or anything. I think if RISC-V has to enter, it will first enter into you know more of a personal computing space than industrial and automotive.
I see.
Fair,
Okay.
fair.
Well,
Because
automotive,
there's one big
I
thing
agree.
that people are that not every company is capable or have resources to make RISC-V microcontrollers. The reason they went ahead, closed their custom processor division, and chose ARM was because of the expenses that you incur when you make your custom processor.
Fair,
Hmm.
fair. I think like the engineering team, this and that, I understand. But
So
then
like say Rust community not Rust RISC-V community provides a lot of tools, like it still does. I know it
Mm,
provides a lot of tools, but if it provides like suits where you can do verification, validation, everything comes from the RISC-V community, a common ground for everybody to follow, where every company doesn't have to put a lot of resources into it. It makes very less sense for like what is the ROI?
okay.
Every company is going to look at the ROI that they're going to get. The royalties are not that much of
True.
a
So
pain from us.
right. So I was thinking along the lines of, let's say you have an open RISC-V core that's available on GitHub, created by open source community, the validation and verification done by individuals or some small groups, whatever. So I'm thinking that for a company, doesn't it make sense to take that not certified, but what a proven core RTL, the very log for it, and then send it to fabs directly, and then you don't pay royalty to anyone. uh,
Okay, so the problem with the open course is there is no dedicated customer support as well, right?
Fair. Okay, so if you are in trouble, then good
Hmm.
luck to you.
Let's buy
Companies
if
like
you want to. Sorry, I would want to add
companies
one
like
point.
WD etc. can take this, can do this, okay, because they are the manufacturer of their or they are their own OEMs. They make
I
their
see.
hard drives. They can be like our chip division will make RISC-V. We know our internal RISC-V. We know our extra final
Mm,
product that's going to go out. So they can do it, and it's a personal computing space. But let's say
mm.
if I am a company, I'm making a chip for let's say BMW.
BMW needs
Unless
like
BMW
support.
is interested in moving in RISC-V and they ask me to move to RISC-V, why would I risk my pipeline? Design that as I have done for so many
I
years.
see.
I
Understand.
have
So
to invest very less in moving people over there.
Right.
So
So what?
it's
Hmm, go
so
ahead.
I
Sorry.
think the majority of the people who are moving to RISC-V are the people who control their own product.
Got it. So, and that is true for personal computing space, where
Yeah,
the specifications are not governed by your customers, but in
yeah,
automotive, that's majorly not the case. Like the customers, the biggest customers will control everything from what you
Hmm.
yeah.
use, what you develop.
So
And
basically, what I'm saying is, unless it comes from your customer, right? What nobody wants to take the risk because it's a very sensitive market, right? You don't want to spend so much and lose the margins. So
mm,
unless somebody big comes and like this revolution of RISC-V has to come from product vendors, the final product
mm,
makers.
mm,
Hmm.
understood.
So, for example, let's say tomorrow, if an automotive industry comes with a standard of RISC-V cores, etc., be like if XYZ meets this RISC-V core, yeah, blah blah blah. That then only it will motivate a semiconductor industry to move to RISC-V on a very big scale.
I have like another angle on this. Let's say the chip manufacturer. So let's say you make some hair dryer, for example, right?
Hmm.
And you take a chip from me, which is ARM based, for example,
Yeah,
costs you, let's say, $10 for simplicity.
yeah.
It might cost you like way less, but let's keep it at 10. What if I come and tell you, hey, I have this RISC-V chip, and I can sell that to you for, let's say, $5. Let's say my margin on the $10 ARM chip was maybe $4 because $6 I had to give to ARM, just for example. I know the margins or the royalty is not so huge. And now if I sell you, let's say, a RISC-V chip at, for example, $8, then let's the manufacturing cost for me, or all external expenses for me is $1, so I'm making $7 on that chip. So isn't it in my favor to also nudge you to go towards RISC-V, just because
Oh
I
well,
make a lot of profit and you save on your expenses as well?
that's the point. You don't save this much.
I see. Okay, you're saying the numbers are different.
The numbers are very less. What you save. I tend to. I don't know what the actual number it goes, but how many places does ARM processor goes
I think.
today?
Oh, you're saying cost?
No, the number of chips that are based on ARM.
Oh, I would say
Think, man,
it's
billions
just
and
like
billions.
salt.
Yeah.
Yeah,
Yeah,
like my
just go
watch
and look
might
at
have like any between 10 to 20, I suppose.
Hmm.
just go and look at ARM's revenue.
Ah,
Hmm.
okay. Like the royalty that comes to them is like
Pennies.
pennies.
Pennies. So it's
And also, sorry,
the
sorry,
major
Rajat,
cost
Rajat.
is not design. The major cost is manufacturing, and you are not addressing that over there.
Mm,
And plus, I think you have to also, provide an entire solution, right? Just the
Yeah,
chip just won't work. You have to provide the complete package because
yeah.
just for the lesser amount of savings, the OEMs don't have much of an incentive to actually move everything to
Yeah.
RISC-V.
And
I,
again, I would go to the perspective people who will like RISC-V and move to RISC-V is those who make their own chips for their own products. For example,
understand.
Western Digital and Sandisk making
Hmm.
memory chips, memory controllers for their memory. Now the
Hmm.
thing is,
Mm,
ARM doesn't provide them flexibility to
Hmm.
do so much changes in design, but with
Hmm.
RISC-V they can do it. So for
mm,
them, they can create a product differentiation by going to RISC-V.
understood.
But if my OEM or my own the customer I'm going to sell the product doesn't care about whether it is RISC-V or ARM, he just wants a processor that can move stuff around.
Hmm,
Hmm.
What's the ROI in me going and doing a custom processor?
Hmm.
Hmm.
fair. Makes sense. Makes sense. I think maybe I can speak to our point, and Mohammed, you can add more to it. So we were coming from the angle of microcontroller class first, and then
Hmm.
the application
Hmm.
processors.
Hmm.
And by application processors, personally, I was thinking about cores that can run, let's say, a high
Full-fledged
level OS,
OS.
yeah,
Yeah.
like Linux and Windows and stuff like that. So to me, it seems that RISC-V entering the state machine kind of
Hmm.
market, where like windows of the car, going up
Hmm.
and down, those kind of applications are where RISC-V can shine. Just a simple state machine, ovens, for example, hair dryers. But I'm thinking that the application processor class, something that can run, let's say, the Chrome browser or the higher level OS, I think RISC-V is far away from that. And to me, it makes sense that they go in this direction because you can introduce the core in the market that does microcontroller
Hmm.
stuff, which is state machine kind of thingy, and then improve on that, and later on, develop a application class processor. So
Well,
you are saying
I'm
the adoption. Let me just quote you again.
yeah,
You're saying that the adoption will happen when the customers, the application hardware application creators nudge that we want a RISC-V
yeah,
processor. The hairdryer guys come and say we want a RISC-V
Hmm.
processor. What you were not referring to is the class of the processor, which is can
exactly.
it
Hmm.
run a Chrome browser? Yeah, okay, fair. So
So,
I suppose we are on the same page
Yeah.
then.
yeah, actually, the other way around is happening as well, right? So, for example, if you take companies like Apple, Qualcomm, who anyways take their ARM processor and modify as per their
Hmm.
requirements to increase the performance, they are just buying ARM for its ISA because a
Hmm.
lot of software is going to run on that ISA and
Yeah.
they don't want to write all that software again.
Fair,
Hmm.
fair.
It's not like they don't have the power to create a custom processor.
I mean, they can, yes, but then
They
you
can,
need the
if they want,
implement.
they can create a custom instruction. But the problem with the custom instruction is that now you need to write all that, to recompile all that software, everything to
Which is
make to
just
work
not
with this.
possible. Like
Also, the
That
because.
this was the problem exactly with Intel and ARM, right?
Hmm.
People know they can do it on ARM, but everybody was like the software
Hmm.
community that Intel has built on top of it. It is gonna be pain to move
Hmm.
things, and
I
even
think
it took time for Apple as well. For a long time, Apple was running apps in emulation mode as well.
right, the
Hmm.
Rosetta
Yeah, the
translation.
Rosetta,
Hmm.
because it's simply not possible overnight recompiling all the software and get it working for ARM.
Yeah.
Well, yeah, you need the libraries to be ported also. Like
Yeah.
your layers
Mm.
might be compatible or compiled for ARM, but some library somewhere is not
Hmm.
available for ARM's one.
So this is the place where I see RISC-V can take over, where companies who are already doing customization of the CPUs and were relying only
Right.
ISA that is publicly that is available for that software, that there are common libraries that can be compiled for that ISA. So I think maybe Apple again is going to do something in this direction, or Qualcomm is going to do something in this direction. I think Qualcomm also announced something like this for watch system, for VR system,
I
that
see.
they are going to do RISC-V based processors.
Yeah, I would expect that the small subsystems, let's say Wi-Fi, sensor
Yeah.
subsystem, that can start to be battery management, that can start to be based out of RISC-V.
But
The
there's a
other
catch is, Piyush, RISC-V has to prove its power efficiency just like ARM has.
Right,
Because
sure, sure. So
mm,
there are companies like Sci-Fi who would
mm,
be doing some experiments around that
mm,
just because they want to sell their
sell their stuff.
chips
Yeah.
also,
So
right?
Mm.
yeah, so even if you look at Sci-Fi didn't do a microcontroller class processor first. They did an application class processor first.
When
Is
okay,
it?
when you mean wait, hang on. I think the application keyword here has dual meaning.
Means which is more comparable to ARM A than to ARM M. The
So
first
you're saying
processor that they did
Sci-Fi
was,
went in the direction of ARM A equivalent?
yeah.
I'm surprised because
I
I
think
would.
Yeah.
H3 something there. They had some. Let me get that exactly name. But their processor was nowhere in M category.
I suppose their
It
first
was a
line of
bit core.
processor is it because I suppose their first line of
It
product
was a
is in the M
TiVo,
class.
yeah, TiVo board or something, right?
No, no, not TiVo board. Wait, Hi-Fi. I remember it was Hi-Fi Rev B, Rev One, something like that.
Yeah. So P650.
P650
So it
Freedom.
was
Can you look for the Freedom Everywhere core? There was a Freedom
yeah,
core or something. Let me also look that up. Man, okay,
sci-fi
this is
freedom
interesting.
core.
All of a sudden. Okay, so their IP portfolio is interesting.
U74 core is the one you are referring, right?
You said maybe not the E class. I think E was for the embedded class, and then there
Yeah.
the U. Well, I don't know what U.
I think it is
User.
Hi-Fi One, Piyush. Freedom
Yes,
Everywhere,
yes.
Hi-Fi One. which is
Yes.
also discontinued.
But was that like the first
I
line of
think
processors they
that
made before they went to?
Yeah, so
Or
they
maybe,
have four categories: performance, automotive, intelligence, and essential.
mm-hmm.
Out of which I see essential being 8 stage pipeline, 64-bit rich OS. Okay, and performance also being out of order something.
But
There
this
is E class, which is automotive.
embedded class.
hmm.
I see.
Yeah,
E class might be the
Yeah, yeah.
embedded one, and I suppose that came out first. We'll need to go into the timeline of
yeah.
which
Anyways,
chip came.
but if you even if you look at their portfolio now, E class is they more have high performance processors than E classes.
I see. So you're saying the performance scores are towards like vector
Because it's easy
operation
to
and
replace them, right? The majority of the software comes on Linux. It's easy to replace them. There is no custom software that has been written for them. It's a
I see.
generic software that is going to run on top of them.
Understood. Fair. Fair.
So
I think
it's easy
I'm.
to do those kind. It's easy to replace those kinds of processors
Hmm,
if specifically you are doing your own custom design.
hmm.
If you are designing you just need an ISA, then it is easy to replace those ones. But in automotive, people are less concerned about core than the surroundings around it. For
Right. Right.
example,
The
in
ecosystem.
industrial automation, people are more worried about Ethercat running than whether ARM is controlling it or a RISC-V is controlling it or a PIC is controlling it.
Understood. Understood. Well, I suppose one other thing that I see happening is the universities were,
Yeah.
trying to teach Intel and ARM architecture, but they like the computer architecture guys cannot do research because you got to buy the license from ARM, and like the modification of the ISA, there is like a license related to that, and that's like extremely expensive. So I suppose for the future, the universities are starting to, like, for example, the Harris and Harris book now is based
Yeah.
out of the RISC-V or based on the RISC-V architecture. So I'm hoping that in the coming years, RISC-V will slowly start to become more popular in the universities, and then you have engineers coming out who know RISC-V a lot better than ARM and Intel, and then slowly, the engineer, like the worker pool, shifts the focus towards new technology. For example, there are a lot more C++ coders than there are C coders.
Yeah.
So now a lot of firmware are like, well, this comes from Lex Friedman's podcast somewhere, where some Facebook executive was invited and he was saying that they cannot hire C++ or they're not finding enough C++ developers. So they now are hiring for JavaScript kind of thing. And, pivoting on the I'm completely misquoting this, but something of that nature was happening there. By the way, that said, can we maybe conclude by talking about what are the skills and what are the good to know topics for anybody who is considering a career in embedded? Can we just maybe touch upon that and then conclude the talk for today?
So, hmm. So I think C is always going to be there. I don't know how do I
Yes.
cut off it. But I would like to add new name into it, and
Okay.
I do see a future coming for it. And I
Okay.
know everybody understands what I'm going to say.
Yes, say it.
Yeah.
Literally.
I think
Can't.
Rust is going to grow. Rust is going to
Examples.
grow.
Hmm.
Okay. So you're
सी को थोड़ा थोड़ा जंग लगने वाला है.
Acha, oh nice, nice. He's going to get rusted. Nice.
Yeah.
Fair.
So don't get me wrong, it's not going to happen in like next 2 3 years or so.
It will
Some
take time. Yeah, it will
we
take
still have a lot of time, but if you are fresh in college, like if you are starting your journey, I would recommend that you should start reading Rust a bit.
Hmm.
I see. I see. Keep that on
Like
your
I
radar.
think down the line, 6 7 years down the line, I think Rust is going to be a differentiating factor
I
in
see.
hiring.
I see.
There are going to be more Rust specific jobs coming up, specifically in kernel space, OS space, etc.
Hmm.
Fair.
And recently, there is a company called Ferris Systems. I guess they provide compilers and Rust trainings, etc. they are working towards getting Rust function safety qualified, Rust
I
compiler.
Hmm.
So that opens Rust door into the automotive industry. And
I suppose once.
automotive industry is a place where I see that there are benefits of having Rust because it cuts down some of the processes that they have as part of 𝘂𝗍𝗍, etc.
I see. I understand. Like the software needs to be
The
qualified
static
and
analysis,
ISO checked.
the static analysis, dynamic analysis, etc. Some of these things which comes inbuilt into the Rust compiler itself,
Hmm.
Right.
so they don't have to pay big fees to the different big license fees to other companies to develop a static analyzer for C, etc.
Fair. Cool. Okay. Well,
So
okay. Mm-hmm.
that's my
I
C,
think.
Rust, and
C
obviously
and
computer
Rust.
architecture.
Hmm.
C,
Fair.
Rust, and
C.
computer architecture.
Fair. C, Rust, and computer architecture.
I
What are?
would, yeah, I would
Yeah.
want to add two things which are, obviously different from what Rajat said, because he already covered the most important thing. So one would be, I think, the nitty gritty details of, how everything is packaged. When I mean everything is packaged, meaning, you have different source files, right?
Hmm.
Uh, you want to generate a binary which runs on a small microcontroller or
Hmm.
a R class core or something like that.
Hmm.
Now, because in college people have moved towards higher level languages, Python being introduced so early, that sort of abstracts us out, how everything is packaged, how everything works at the low level, which is very much core knowledge in embedded, and which I think people should still take some time to know more about. So, for example,
Right.
build files, build systems, linking, how linking works, right? How loadable module works, what is position independent code, how a library gets loaded and linked at dynamically at runtime, stuff like that. Which I suppose it's now sort of, because most of the people don't require it to know.
Hmm.
It is not being taught that well.
But also, I suppose if it
Hmm.
is taught, who is actively learning that?
Actively learning, yeah.
If it is not used in daily life, then
Hmm.
people typically
True,
don't.
true. Yeah,
When your brain doesn't remember it.
yeah.
Fair. What else? What other things are we talking about? Wasim,
I
Dave.
think I think we forgot the microprocessor
I see.
subject. Yeah,
So computer architecture is something
Computer
that
architecture.
Rajat
yeah,
nudged out. But computer
but
organization also helps.
Yes.
Right.
right,
I think with microcontroller, computer organization might be a good subject to focus
right.
on.
I think in college these are two different subjects. So
Yeah.
yeah,
So let me maybe call out the difference. Computer organization is the compute unit and other peripherals interacting
Hmm.
together to
Hmm.
achieve
right.
something.
The memory,
Computer,
all
arch-
those things.
yeah. Computer architecture is just the CPU and the
CPU,
internals
yeah.
of it, the design
Mm,
of it, so to speak.
right.
So yeah, organization is something people can focus on.
I would
Yeah.
like to add like little bit of automation, like shell scripting automation or Python automation
Hmm.
will be also helpful if
Yeah,
you're
fair.
Yeah,
Hmm.
Fair. Now that we are talking about all of this, I want to throw in that people should like definitely focus on computer architecture, but then also maybe try out writing some hardware in Verilog. Just because it gives you a different perspective into how
Hmm.
electronics works, digital electronics
Yeah.
works. You kind of can predict how a CPU would operate and how it might be doing things, what a cache is, what registers are, what memory is. It makes a lot more sense. So
Hmm.
yeah,
And
not
also
that
the
it's
process,
mandatory. It's just that it helps.
yeah,
And
and the hardware synthesis process as well, right? Complete. Like what is
yeah,
DV, what is place and route, what is timing closure and stuff like that.
I will add a controversial
sure.
subject.
And we will end at that. We'll not elaborate. Go ahead.
Data structures and algorithms.
Okay.
No comments.
Not from the point that you should cram it. You should definitely study it because
Hmm.
it opens your mind to the possibilities that can be achieved.
Yes.
Not it's not like if you don't know DSA you won't succeed. It's just that it makes you a better engineer.
Yeah. And
Just
for
like knowing
again,
Verilog, if you know Verilog, it will make you a much better engineer. If you know computer architecture, it will make you much better embedded engineer.
right.
Similarly, if you know DSA, it will make you, it will open your sight and open your mind for certain things.
Yes,
But definitely
the
not a necessity.
solutions that you come up with are a
Hmm.
little more
Yeah,
elegant. Uh,
yeah,
by the way, at that point, I'll just kind of, you know, say that I have, like, recently, it was just recently that I and one other teammate of mine were talking about using trees and graphs to implement like clock management related software. So you have, like, the clock going from one point to other point, and at very, like, at every different point you can multiply or divide the clock. The question is, at the final point you need a clock which is, let's say, 10 hertz, for example. Now you got to set the PLLs all the way up to the top, and then there is a tree of those. So how do you manage it? It is a tree. You have a
yeah,
database, and you have to keep track of stuff as trees.
yeah.
Yeah, this is
The
a good
trees are
example of people asking where to use DSA in embedded. So
embedded. Yeah.
Well,
It's not like you will
well,
use them always, but once
yeah,
you're trying to solve a problem like that, well, DSA comes in handy.
well,
yeah,
you have no choice over there. The
Yeah.
clock themselves are represented as trees.
Trees, exactly.
It is the terminology itself is called a clock tree.
Clock tree. Yes. Yes. That's that.
So the only way you can parse it is by a tree algorithm.
Tree, yeah. But then,
Tree clock algorithm.
like, people do say, hey, where do you use,
Yeah.
DSA in
No, but
embedded?
the trick
But
comes
not
in
often.
where, sorry, when the trick comes in that you have, only static allocator in place, and now you need to make it behave like a, dynamically allocated data structure, which is where I suppose,
Hmm.
the most of the thinking would go in, right?
Yeah.
How do you make array behave as a tree, and yeah,
Yes.
Yeah.
all those
Well, again,
obviously.
these are like implementations of
Hmm.
tree data
Yeah,
structure, right? You can have, like, an
multiple
array and
array
different
pointers to.
elements. Yeah. Yeah, all of
Okay.
those. But anyways, then maybe we should just conclude at this point, and other podcasts we can catch up or discuss more on the topic of, like, maybe DSA in embedded or embedded jobs, skill set, all of that.
Maybe we should continue with the interviewing series as well.
Yeah, yeah.
Yeah.
We should revisit
Hmm.
and maybe continue
Hmm.
to discuss on everyone's career journey so
Yeah.
far and how we got here. Cool. All right.
All
Then for
right.
today, we can conclude our call. And for those who stayed back this long, thank you.
Awesome. You are
And
awesome.
thank
Thank
you.
you very
yeah, you're
much.
awesome. Yeah, thank you.
Bye bye.
All right. Cool. Bye bye.